Yeah, Notion. Good evening. It's already completed in the morning session. So we'll discuss about. Hello, hi everyone. Welcome to the Students Brand. So this is our Siva sir. Today we are going to discuss about. Today we are going to discuss about magnetic effects of electric current. Magnetic effects of electric current. Okay, so we can consider this one. Magnetic effects of electric current. Magnetic effects of electric current. Magnetic effects of electric current is nothing but when the current is passing through the conductor, when the current is passing through the conductor. Hi Daniel. So welcome to the class. So when the current is passing through the conductor, so it act as it exhibit it behaves as a magnet. It behaves as a magnet. Magnetic effects of electric current. Magnetic effects of electric current by passing the electricity through the conductor. So it behaves as a magnet. So the magnetic field will be produced. Magnetic field will be formed around the conductor. So we'll discuss about everything. Okay. First of all, we'll discuss about magnet. So what is magnet? How it will be there? So we will discuss all those points. So magnet is nothing but the substance which influence or which attract the magnetic material. The substance which attract the magnetic material, that is called magnet, or which have property of attracting or repelling the objects. So that also we can say magnet. So there are two types of magnets are there: artificial magnet and man-made magnets. Artificial magnet or man-made magnets. Like one more magnet is natural magnets. One is natural magnet. Another one is artificial magnets or man-made magnet. Man-made magnets are also called artificial magnets. Artificial magnets. Okay. So we can observe natural magnet is nothing but magnetite is a natural magnet. Magnetite is a natural magnet are also called lodestone. It is also called lodestone. Magnetite or lodestone. That is called natural magnet. Magnetite or lodestone is called natural magnet, natural magnet. Okay, so here the magnet has two properties. One is attractive property, another one is directive property. So how it will be there? So first we will discuss about magnet. We will discuss about magnets. We will discuss about magnet nature, everything. Okay, so normally if you are taking natural magnet is, so magnetite or lodestone, right? So if you are taking, if you are considering around it, magnetic field will be created. Around the magnet, magnetic field will be created. Around the magnet, magnetic field will be created. So how it will be, how the magnetic field will be there, how the field lines will be there around the magnet. So how much distance it will attract, more than that it will attract or not, so whether it will be there or not, so how much range the magnetic field will be there, everything we will discuss. Everything we will discuss about magnet in this class. And after that, so electromagnet, when the current is passing through the conductor, it acts as a magnet. So that also will discuss. First of all, we'll discuss about magnet. Okay, so magnet, if you are taking magnet, okay, so it has a property of attracting or repelling the substances around it. Okay, so artificial magnets are bar magnet, u-shaped magnet, dumbbell, cylindrical magnet, spherical magnet. These are all called artificial magnets, according to the requirement of uses of the magnet, according to the requirement uses of the magnet. So uh, we made those magnets. Those are artificial magnets. So those are bar magnet, cylindrical magnet, spherical magnet, like that. So different types we are using, so now we will discuss about bar magnet. Particularly we will discuss about bar magnet will discuss. So I am taking, so now magnetic magnetic effects of magnetic effects of electric current 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 magnetic effects of electric current. Okay, magnetic effects of electric current, we will discuss about it. Magnetic effects of electric current. Okay, so if you are taking the bar magnet, if you are considering the I'm considering like this is a bar magnet, I'm considering. So this is a north pole and south pole, so actually magnet has two poles, equal pole, so both poles are equal strength. Magnet has two poles, so both poles are equal strength, so equally it will attract. If you drop the magnet, into the sun, what happens? So if you drop the magnet, if you drop the magnet into the sun, okay, so what happens? So the magnetic material will attract at the poles, okay, so poles are equal strength. So each magnet has two poles, that is north pole and south pole. Each magnet has two poles, north pole and south pole. Okay, if you drop the magnet into the sand, so magnet has two poles, equally it will attract the material. So the more magnetic field or more attraction will be there at the ends of the magnet, more magnetic field will be there, than in the middle. So if you drop the magnet, the field will be attracted at the ends. So that is called poles. Now north pole and south pole, So around the magnetic field will be there. Around the magnet, magnetic field will be there. Around the magnet, magnetic field will be there. Around the magnet, magnetic field will be there. Magnetic field will be in the form of magnetic field lines. Magnetic field will be in the form of magnetic field lines. magnetic field will be in the form of magnetic field lines around the conductor, around the conductor, around the conductor. The magnetic field will be there around the conductor. So around the magnet, if you are taking this a magnet, around the magnet, the magnetic field will be there. How the magnetic field will be there? So the magnetic field will be in the form of field lines. The magnetic field will be in the form of field lines. What is magnetic field? First of all, what is a magnetic field? The region around the magnet. If you are taking the two magnets, if you are taking these two magnets, okay, so if you are taking the two magnets, so at certain, if you are placing, this is one magnet, this is one magnet, if you are placing near to each other, so certain distance each other, so it will attract, it will attract at certain region only. So within this region it will attract the magnet. Beyond, if you place beyond it, so it won't attract the magnet, it won't attract the magnet. Certain distance only the magnet will attract the magnetic material or the region. So within certain region only, within certain region only, the magnet will attract the another magnet. Okay, so that is called a field. So the field is nothing but the region in which the magnetic force exert, the region around the magnet, the region around the magnet in which magnetic force exert, the region around the magnet in which magnetic force exert, the region around the magnet in which magnetic force exert. Okay, that is called magnetic field. The magnetic field will be in the form of magnetic field line. Magnetic field will be in the form of magnetic field lines. Magnetic field will be in the form of magnetic field lines. So the region, so certain distance only the magnet will attract the magnetic material. Certain distance, as I said, certain distance only the magnet will attract the magnetic material. The certain distance only the magnet will attract the magnetic material. So the region around the magnet in which magnetic force exert, the region around the magnet in which magnetic force exert is called magnetic field, is called magnetic field. The field will be in the form of field lines. The field will be in the form of field lines. So if you are taking around the magnet, so here, so I am taking the magnetic field lines, I am considering here magnetic field lines. Okay, so I am considering it will be taken in the form of magnetic field direction. Okay, like this I am taking, like this I am considering, like this. Okay, so I'm considering here. So north to south, north to south, north to south, north to south. I'm considering this the outside, this outside, this outside. I'm taking this outside. So towards the pole, so it will be inside. It will be inside. Okay. So this is the see magnetic field lines. Magnetic field lines emerge from. So means comes out from the north pole, emerge out from the north pole, and merge at south pole. Magnetic field emerge out from north pole, merge at south pole. Emerge means moving out. Okay, so magnetic field lines will move out from the north pole and reaches to south pole. The magnetic field lines. So magnetic field lines are in the form of closed loops. So magnetic field lines are closed loops. So the magnetic field lines emerge out from north pole and merge at south pole. These are closed loops. So outside of the conductor is north to south. Inside of the conductor is south to north. Outside of the conductor is north to south. Inside of the conductor is south to north. So these are always closed loops. So these field lines never intersect. If it is intersect, so compass should show at a time two directions. Where it is not possible. Right? So are you understanding or not? So if you are taking the magnetic field lines, so emerged from north and merges south pole. So these are closed loop, those are closed loops. Okay. So emerge out from north pole and merge at south pole. Those are closed loops. Field lines never intersect. If it intersects, so compass should show two directions. What is compass? So compass consists of a small magnetic needle present inside of it. If you leave like that, always it shows north and south direction. So I'm taking here, this is the north, this is south, so east and west. So I'm taking north and south, east and west, north and south, east and west. I'm taking this one. Okay, so magnetic field will be always, magnetic field will be always, so north to south, and the magnetic field will be always north to south. Okay, outside of the bar magnet is magnetic field is, so magnetic field will be, So outside of the bar magnet, magnetic field will be north to south. Inside of the bar magnet is magnetic field will be south to north. South to north. Understand? So is it clear? Outside of bar magnet is magnetic field will be north to south. North to south. Inside of bar magnet is south to north. South to north. South to north. Okay. So here I'm considering like this once again. Outside of the bar magnet is magnetic field. Outside of the bar magnet is magnetic field is north to south. North to south. Inside of the bar magnet is magnetic field is south to north. Okay. So I hope it is clear. Magnetic field. Magnetic field means around the magnet in which around the magnet. So the region around the magnet in which magnetic force exert. The region around the magnet in which magnetic force exert. The region around the magnet in which magnetic force exert. So the region around the magnet in which magnetic force exert is called magnetic field. Okay. So the magnetic field will be in the form of field lines. So magnetic field lines emerge from north pole, merge at south pole. Those are closed loops. Those are closed loops. So these field lines never intersect. These field lines never intersect. If it is intersect, so if it is intersect, so if it is intersect at the point of intersection, at the point of intersection, at the point of intersection, so compass should show two directions at a time. Where it is not possible, where it is not possible, where it is not possible, it is not possible. Yes, it is not at all possible. If the lines are intersecting, compass should show two directions at a time. At the same point, where it is possible, it is not possible. It won't be possible. That's why field lines never intersect. 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 Right? Yes, so around the magnet field will be north to south, inside of magnet south to north. So those are closed loop, never intersect, never intersect, never intersect. These field lines never intersect. Field lines never intersect. Is it clear? So this is about magnetic field around the magnet. So we are talking. If you want to identify the direction of the magnetic field, if you want to identify the direction of magnetic field at the point, at particular point, if you want to identify the direction of the magnetic field at the point, you have to draw the tangent to the magnetic field lines. Yes, you have to draw the tangent to the magnetic field lines. You have to draw the tangent. How you have to draw the tangent? You have to draw tangent like this. You have to draw the tangent. If you're drawing the tangent, yes, if you're drawing the tangent, then so we can identify the field direction at that point. So if you're drawing like this, okay, so tangent. What is a tangent? What is a tangent? What is a tangent? The line touches the curve. The line touches the magnetic field at one point. At one point. That is tangent. That is tangent. If you want to identify the field at the particular point, so here field will be there, here field will be there, here field will be there, here also field. So around the magnet up to certain distance only the field will be there. Yes or no? Field will be there. So to identify the field at that particular point, if you want to identify the field at that particular point, you have to draw the tangent. You have to tangent to the curve. You have to draw the tangent to the curve. Okay, if you draw the tangent to the magnetic field line at that particular point, the direction of the tangent. So the direction shows that magnetic field at that particular point. Okay, the tangent shows the direction of the magnetic field at that point. Understood? Is it clear? Yes. Now we are going to discuss about one more point. So this is about the magnetic field. If you suspend the magnet, always shows north and south direction. But somewhat tilted, it won't exactly shows perpendicular direction north to south. Somewhat tilted one. So it will be even compass also. If you place like this, okay, so this is north and south, it will be there, somewhat tilted will be there. Okay, even if you take the compass, okay, compass if you are taking also will get it, right? So this is about a magnetic field lines, magnetic field and magnetic field lines around the magnet, and properties of magnetic field lines, everything we discussed, right? So now we are going to discuss about when the current is passing through the conductor. Conductor, 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 conductor. When the current is passing through the conductor, so it behaves, it acts as a magnet. It behaves, it acts as a magnet. It behaves, it acts as a magnet. When the current is passing through the conductor, when the current is passing through the conductor, so when the current is current is passing through the conductor, so if the current is passing through the conductor, I am taking the conductor, so this is the conductor. Mm, mhm. So, introduction song we missed it. The introduction song. Anyway, we'll start now. Introduction song. Shall we? So actually, I created introduction song. We missed it. So we are starting directly. We started chapter. So anyway, now only started. So that is introduction. Now only started, right? So we'll song for you. So I'll sing. I'll sing the song. Okay, ready? Myopia, 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 myopia. Near distance we can see her, far distance we can see her. Myopia, 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 myopia. For that correction we are using concave lens, so concave lens, so concave lens, so concave lens. Hypermetropia, 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 hypermetropia. Far distance we can see near distance, we can see hypermetropia, hypermetropia. For that correction, we are using convex lenser, convex lenser, convex lenser, convex lenser, hypermetropia, hypermetropia. Convex lenser, convex lenser, hypermetropia, convex lenser, hypermetropia, convex lenser, myopia, concave lenser, myopia, concave lenser. Cartesian sign convention, Cartesian sign convention, all distance measured from the pole. Distance are positive along the instant race. Distance are negative opposite to instant race. Distance are positive above the principal axis. Distance are negative below the principal axis. Cartesian sign convention, Cartesian sign convention, Cartesian sign convention. All distance measured from the pole. Distance are positive along the instant race. Distance are negative opposite to instant race. Distance are positive above the principal axis. Distance are negative below the principal axis. Say with me, learn with me, sing with me. Dispersion, 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 dispersion. Splitting a white light into 7 colors is known as dispersion. Dispersion. Splitting a white light into 7 colors is known as dispersion. The band of colors is known as spectrum. Refraction of light takes place by the atmosphere is known as atmospheric refraction. Atmospheric refraction. Atmospheric refraction. Atmospheric refraction. Atmospheric refraction. Atmospheric refraction. The phenomena of scattering of all lights in different directions with a different intensity. The phenomena of re-emission of all lights in all directions with a different intensity. The phenomena of re-emission of all lights in all directions with a different intensity. The phenomena of re-emission of light in all directions with a different intensity is known as scattering of light. Scattering of light. Say with me, learn with me, sing with me. Dispersion. Dispersion. Say with me, learn with me, sing with me. Dispersion. Myopia, 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 myopia. Near distance we can see far distance we can see a myopia, myopia, myopia. For that correction, for that correction, we are using concave lens, concave lens, concave lens, concave lens. Hypermetropia, 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 hypermetropia. For a distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. For that correction, for that correction, we are using convex lens, convex lens, convex lens, convex lens. Okay, so actually I created these songs like myopia, hypermetropia, so people can learn in easy way. That is the reason. That is the reason. That is the reason I doing all these songs and so experiments, right? So to do so they can learn in easy way, they can prepare in easy way, they can remember in easy way, and they will recall the topics, they can recall the topics, they can recall the topics, so in easy manner. Okay, so definitely they will learn with fun, so topics. So that's why I'm making all these things. So if you like it, please do like, share, and subscribe to Studying the Brand. So thank you so much for supporting and listening, understanding, and attending the class. So we'll go to the topic, right? So if the current is passing through the conductor, if the current is if the current is passing through the conductor, so if the current will pass from positive terminal to negative terminal, current will pass from positive terminal to negative terminal. So when the current is passing through thick copper wire, so this I am taking the conductor that is as a thick copper wire. If the current is passing around it, magnetic field will be created. Around it, magnetic field will be created. So how the so around it, magnetic field will be created. Okay, fine. So so around the conductor, so there are concentric circles around the conductor. There are concentric circles means, so make it taking as the center of the rod. Okay, so around it, so like a loops, like a circles will form. That is called, those are called concentric circles. Concentric circles. So near to the conductor, the concentric circles will be more. Near to the conductor, the concentric circles will be more. Away from the conductor, the concentric circle will be less, because so the more magnetic field will be there near to the conductor, more magnetic field will be there near to the conductor. If you move away from the conductor, magnetic field will be less. Near to the conductor, more magnetic field will be there. Away from the conductor, magnetic field will be less. Okay. So if you place the compass, if you place the compass near to the current carrying conductor, so it will shows the deflection. It shows the deflection. It shows the deflection. It shows the deflection. So if you place the compass near to the conductor, it shows the deflection, because here also magnetic field is there. So inside of the compass, magnetic field is there. So if you are taking magnetic field, if you are taking north and north, so as already said, so this is a, if we are taking north, north will repel, north south will attract. North will repel, north south will attract. South will repel, south north will attract. South north will attract. So two dissimilar poles will attract. So this will attract, this will repel, attract. Okay. So two similar poles will repel each other. Two dissimilar poles will attract each other. North south or south north. Okay. So two similar poles repel, dissimilar poles attract. Similar poles repel, north repel, south repel, north attract. South north attract. Two dissimilar poles will attract. Two similar poles repel. Two similar poles will repel. Two similar poles will repel. Two dissimilar poles, two dissimilar poles, north and south and north will attract, north will not attract, will repel, north will repel, south will repel, only dissimilar poles will attract, similar poles will not attract, similar poles will repel each other, south will repel, north will repel, north south will attract, yes or no, so this is about we are discussing, now. So we are going to the one more, that is, so if the current is passing through that, so around the conductor magnet will be created, around the conductor magnet will be created, around the conductor magnet will be created, around the conductor magnet will be created. So because the current is passing to act as a magnet, it behaves as a magnet, so it shows the magnetic property. So around the magnet, around the conductor magnet will be there. If you place the compass around the conductor, so there will be attraction or repulsion according to the, so if you are taking, so around it will be, so deflection will be shown, yes or no, deflection will be shown around the conductor, magnet will be there, around the conductor magnet will be there, okay. So current is passing downward direction, so in this case current is passing downward direction, yes or no. So in this case current is passing downward direction, so if the current is passing downward direction around the conductor, okay. So near to the conductor more magnetic field lines will be there, more concentric circles will be there, near to the conductor more magnetic field will be there, more concentric circle will be there, away from the conductor, when you are moving away from the conductor, magnet will be less, so less magnetic field will be there, near to the conductor more magnetic field, away from the conductor less magnetic field, okay. So it depends on the distance from the conductor, near to the conductor magnet will be more, away from the conductor magnet will be less, so if the current is passing inside the conductor, so the magnetic field will be created around it. How can you identify the magnetic field around the conductor? In which rule will use to identify the magnetic field around the conductor, okay. So actually, if the current is passing like this, the compass will show towards the western direction, deflection. If you change the battery polarities, automatically current will move different direction. So if you change the current direction, magnetic field direction also changes. So the final conclusion is, if you change the current direction, if the current is passing like this, so before the current is passing like this, if you are changing the current, so if the current is passing like this, so magnetic field direction also changes. So if you change the current direction, magnetic field direction also changes. Yes or no? So how can you identify the magnetic field around the current carrying conductor? By using right hand thumb rule. By using right hand thumb rule, we can identify, so in which direction magnetic field will be there by using right hand thumb rule. So if you are taking the thumb, thumb shows along the current carrying conductor, so thumb is showing the around the, so in the direction of the current flowing, okay, thumb. So folding fingers, wrapping fingers, so thumb shows along the current carrying conductor direction, four leaf fingers, curly finger shows the magnetic field direction by using right hand thumb rule, by using right hand thumb rule. So if you are taking the thumb along the current direction, so folding fingers, curly fingers, folding fingers shows the magnetic field direction, yes or no. Now we are considering here, around it magnetic field will be created, yes or no, current is passing like this. Okay, so by using right hand thumb rule, we can identify if the current is passing. So if you are taking north and south, if the current is passing upward direction, so the magnetic field will be like this. If the current is passing downward direction, so magnetic field will be like this. So if you are taking clockwise or anti-clockwise, so it will be clockwise direction. This is clockwise. This is clockwise. Okay, clockwise, and this one is anti-clockwise, 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 anti-clockwise. So with help of clockwise and anti-clockwise, if the current is passing downward direction, the current is passing downward direction, magnetic field will be clockwise direction. If the current is passing upward direction, so this is current I and this one is current I. So if the current is passing upward direction, so magnetic field will be anti-clockwise direction. Magnetic field will be anti-clockwise direction. If the current is passing downward direction, magnetic will be clockwise direction. So very important, very important, very important. By using right hand thumb rule, right hand thumb rule, by using right hand thumb rule, by using right hand thumb rule, by using right hand thumb rule, we can identify the magnetic field around the current carrying conductor. By using right hand thumb rule, we can identify the current we can identify the magnetic field around a current carrying conductor. Magnetic field around a current carrying conductor. So I hope it is very clear. I hope it is very clear. So right, next one. So we are going to the next one. Here till now we have discussed about okay, current is passing to the, so straight conductor also will be the same. Straight conductor also will be the same. So if you even require normal wire also, if you are considering same. So if you are taking the loop, 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 if you are considering the loop, if you are considering the loop, if the current is passing inside of the loop, how the magnetic field will be there inside of the conductor, how it will be. So we'll discuss now. We'll discuss now. So I'm considering the loop, single loop I'm taking, single loop I'm taking, single loop I'm taking. Okay, so I'm taking this one. Positive, negative, current is passing like this. Okay, so around it. Okay, so I'm considering. So at the middle it will be north and south. Okay, so it will be leaving. Okay, so in the middle it will be uniform magnetic field, uniform magnetic field. Okay, in between it will be uniform magnetic field. I'm considering. Okay, so see, you can observe here. Okay, so current is passing, positive terminal, negative terminal. Current is passing in the loop. So by using right hand thumb rule, so by using right hand thumb rule, we can identify the magnetic field around the current carrying conductor. We can identify the magnetic field around the current carrying conductor. So here you can see this is an north pole, this is south pole. So if the current is passing like this, the magnetic field we are taking here. So here also, so if you are considering here also, so here, so the thumb, okay, right hand thumb rule, if you are placing like this, the magnetic field will be like this. That's the reason. So this side is north, this side is south. Okay, so here if you are keep on increasing, so from here to here, so what happens here exactly you can observe here. So when the magnet will be created, so it will be like this. So when you keep on going at the center, exactly at the center, those lines will become parallels. So this magnet field, one magnet field will be added to another magnet field. This magnet will be added to another magnet field. This magnet field will be added to another magnet field. So then the uniform magnet will be created at the center. So the more magnetic field will be at the center than at the circumference. This question they will ask. So magnetic field will be more at the center than at the circumference. Magnetic field will be more at the center than at the circumference. Very important. So this question, this concept. Okay, next one we are going to one more, that is solenoid, 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 solenoid. So here I'm taking here I'm considering. So you can take a insulated copper wire, so wound in the form of cylindrical shape. If you are taking the straight copper wire, so wound around the conductor are in the form of cylindrical shape. So taking the straight wire, so wrap in the form of cylindrical shape, wrap in the form of cylindrical shape. I'm taking like this. Okay, so you can take it as a, you can consider here, So current is passing. So this is solenoid. You can see this is solenoid. Okay, so when the current is passing inside of the wire, so it acts as a magnet. It behaves as a magnet, as like a bar magnet, as like same bar magnet. What are the properties of the bar magnet? So like so it emerge north pole, merge at south pole, emerge out north pole, merge at south pole. Within the region, magnet field will be created. Okay, so here the point is, so when the current is passing through the circular loop, so like many rings are there, number of turns are there. We can say number of turns. So these are the number of turns. Number of turns are there. So the gap is there. If the current is passing, it behaves. It acts as a magnet. It acts as a magnet. Around it, magnet field will be there. Around it, magnet field will be there. Okay. I hope it is clear to you all. One check it. One check it. So I'm taking here. I'm considering here if the current is passing. So it behaves, it act as a magnet. So it behaves, it act as a magnet. Magnet will be created around it. Okay, so however the bar magnets, however the bar magnetic field, so it's same as it is for the solenoid also, as it is for the solenoid also, as it is for the solenoid also. Okay, so here the point is in the bar magnet, you can understand one thing in bar magnet. I'm taking this a bar magnet. This is a bar magnet. This is a bar magnet, and here is a solenoid. Solenoid. Solenoid I am taking here. Okay. So in the bar magnet, magnetic field is fixed, north pole and south pole. So here in the bar magnet, so magnetic field will be fixed. Here in this bar magnet, magnetic field is fixed. Magnetic field is fixed. Magnetic field so will not change. Whereas in a solenoid, so if you strength of current, if you increase the current, automatically magnetic field will be increases. If you increase number of loops, if you increase number of loops, also magnetic field will be increases. So the air gap, if you are increasing gap between the rings, also magnetic will be more. If you are increasing more gap, then automatically magnetic field around the conduct around the loop also will be more. So here magnetic pole strength is fixed. Okay, so we can't change the poles, but he can change the polarity. So here north pole, here south pole. So we mentioned, right. So if you change the battery polarities, automatically current direction changes. Automatically poles also changes. But here, so we can't change the poles. 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 So poles we can't interchange. So poles are fixed only. Poles are fixed only. Poles we can't change. Poles we can't change. So strength will be same. Strength will be same. Here strength will be varies according to the strength of the current, according to the number of loops, number of rings. According to the number of rings, strength will be increases. If you increase the number of turns, also magnetic field increases. So if you increase the current, magnetic field increases. If you increase the number of turns, number of loops, then magnetic field also increases. Magnetic field also increases. Yes or no? Magnetic field also increases. This is about solenoid. This is about bar magnet. This is about bar magnet. And the next one, one more point we'll discuss about it. That is, So now you can see if the actually we know if the current is passing the conductor, if the current is passing the conductor, it acts as a magnet, it behaves as a magnet. So that conductor we place the external magnetic field. This is the horseshoe magnet. This I'm considering the horseshoe magnet. So this also magnetic field, external magnetic field. So this is a conductor, current carrying conductor placed in the magnetic field. So when the current is passing through it, it acts as a magnet. So this magnetic field is placed in the external magnetic field. Then so repulsion will be there. So the force will act on the conductor. The force will act on the conductor. On the conductor, the force will act. 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 On the conductor, force will act. In which direction? In which direction? In which direction? In which direction the force will act on the conductor? In which direction the force will act on the conductor? In which direction the force will act on the conductor? So actually by using Fleming left hand rule, by using Fleming left hand rule, we can identify the force acting on the conductor. By using Fleming left hand rule, we can identify the force acting on the conductor. So index finger shows the magnetic field. Index finger shows the magnetic field. So middle finger shows the current direction. Thumb shows the force acting on the conductor. Thumb shows force acting on the conductor. Once again, so index finger shows the magnetic field. So here middle finger shows the current, and thumb shows the force acting on the conductor. Now by placing here, so current is passing downward direction, magnetic field will be upward. So the force will act on the conductor into the board. The force will act on the conductor into the board. The force will act on the conductor into the board. The force will act on the conductor into the board. Right. So this is about current carrying conductor placed in the external magnetic field. External magnetic field experience the force. Very very important 5 marks question. Very very important 5 marks question. Solenoid is very important 3 marks, and bar magnet is very important 3 marks. Solenoid is very important 3 marks. Bar magnet also very important 3 marks. So magnetic field around a solenoid, magnetic field around a bar magnet, and difference between solenoid and bar magnet. Difference between solenoid and magnet. Bar magnet also we have to learn. And this one also, this one is very very important 5 marks question expected from magnetic effects of electric current. So this question and explanation, Fleming left hand rule. So Fleming left hand rule, stretch the 3 fingers of left hand, the thumb finger, index finger, middle finger perpendicularly. Thumb finger, index finger, middle finger perpendicular to each other, so index finger shows the magnetic field, so middle finger shows the current, and thumb shows the force acting on the conductor. Thumb shows the force acting on the conductor. Thumb shows the force acting on the conductor. This is about Fleming left hand rule. Fleming left hand rule. Fleming left hand rule. Fleming left hand rule. I hope it is very clear to you all. Very clear to you all. So this is about current carrying conductor placed in external magnetic field experience the force. And we can take earthing is nothing but whenever the extra current is there, so that will send to the ground. Extra current is there, that will send to the ground. Fuse is a device, safety device, which is connected to circuit. Okay, whenever the extra current goes, so other than the rating limit, so then it melt and breaks the circuit. It melt and breaks the circuit. If say it safeguard the appliances, it safeguard the appliances, Okay, so that is about the fuse. Short circuit, the direct contact of live and neutral will takes place. The direct contact of live and neutral will takes place. Then heavy amount of current will be drawn from the mains. Then it leads to the fire in the building. Overloading, high voltage appliances on at a time. High voltage appliances on at a time in the circuit. High voltage appliances like geyser, washing machine, fridge, like different appliances if you on. Okay, high voltage appliances if you on at a time in the circuit, it draws heavy amount of current from the main. So insulation of the wire made then, so direct current of a live or neutral will takes place. Then it will leads to the fire in it leads to the fire occurring in the building. Okay, so this is about This is about overloading. This is about overloading and short circuit. Next one, live wire is a live wire. I'm taking live wire. Live wire is nothing but positive terminal. Live wire is the positive terminal. So potential difference is 220 volts. Neutral wire, neutral wire, neutral wire. Okay. So live wire is positive terminal, positive terminal. So then live wire, live wire, live wire, red color, potential difference is 220. Neutral wire, negative terminal, potential difference is 0 volts. And earth wire is green color. The potential difference between live wire and neutral wire is 220. The potential difference between live wire and neutral wire is 220. 220 volts. First one. Coming to the next. So the potential difference between live wire and earth wire is 220 volts, and the potential difference between neutral wire and earth wire is 0. The potential difference between neutral wire and earth wire is 0 volt potential. So here the potential difference between live wire and neutral wire is 220. The potential difference between live wire and earth wire is 220. The potential difference between neutral wire and earth wire is 0. Okay. So this is about so this is about okay. So electrical wiring and series and actually electricity and continuous topic. This also very important. Okay. So hi everyone, welcome to the class. So hi everybody, I can understand. So there are so many things to discuss due to class. So continuous class is going on. That's the reason I couldn't able to interact. So definitely I'll interact. So every day at night, 11 or 12, 11:30, around 12 o'clock. So around 11:30. So maximum 11:30. That time there is a session talk with me. So why this class? Why this type of dress things? I like that. If you want, if you want more clarity, sir, I won't wait until that time. Please tell the answer. Means you can check my channel. You can check my channel. You can check the videos. Whatever it is there in my channel. Yeah. So whatever it is there in my channel, then you'll get all the things, all your questions, answers. You'll get it. So for all your questions answer you'll get it. Check my channel, check the videos, and I did many videos, lot of videos, nearly there are so many experiments, so many activities, so many experimental videos related to physics only, related to physics only. So yes, so I am fine. Dr. Parth, I am fine. So thank you so much for asking. And remaining students, so just check the videos and watch the videos. So let me know. So if you have any doubts, you can call. So you can contact me if you have any doubts. 9849812804. If you need any classes regarding not only physics, regarding maths, chemistry, biology, social, English, like remaining languages also. If you need classes, if you want classes, you can contact to that number. Okay, through that number you can contact. WhatsApp, try to send a WhatsApp message, we'll discuss. Okay, so this is our sir. from Studio in the Brand. Thank you so much for joining and attending and interacting to me. So thank you so much. We'll see you soon. Again 9 o'clock. Again 9 o'clock. I will start a live class. So with a different topic. Definitely, definitely. Thank you so much. Thank you so much. Okay. So if you like this content, thank you so much, Pat. So if you like this content, if you like this channel, so please inform to your friends, share to your friends. If they like it, let them join, let them listen the class. If you have any doubts, you can ask. So you can ask related to physics if you can ask. So thank you so much for joining, and do like, share, and subscribe my channel, and do support. So I need your support. I need a lot of support from you all. So thank you so much. That's enough. I can't say more than that. Thank you.